Edward, can you cut the lights? Thanks. I mean, that was fine. It's fine. Okay. All right. So today we're going to be talking about, hold on, let me pull up my notes. What happened to the whole packet I gave you? All right, ladies. Today we're going to be talking about calculating limits algebraically. Calculating limits algebraically. So right now we've been calculating limits using graphs. Now we're going to use actual numbers and math. We will be combining graphs and numbers and equations as we do new things, okay? So we've done the graphs part, we've done the limits of graphs, we've done the limits to infinity. Now we're going to do the limits using algebra or arithmetic, okay? Just like I've been telling you or, trying to do, I'm going to be giving you level 1 questions, level 2 questions, and level 3 questions. But all the laws and the rules that we're using today will apply for all of those levels, okay? So if you look on the sheet that I gave you, there's a level 1, level 2, level 3 questions, right? So we're going to go through the laws, and then we're going to do the examples. Now, like I told my other classes, I'm always giving you a level 1 attainable standard, always. That's what I'm always doing. So there's no reason, I see your face, there's no reason for you to not be getting level 1. Level 1 is a 70%, 73? I don't even know. You dear. So there's no reason we should not be passing this class, okay? Oh, I'm sorry. I'm sorry, Mia. That was an accident. Sorry. I forgot. Okay? Make sure that you are attempting level 1. There's no reason any of you should be getting a D in this class. At all. 0 Ds. 0. 0. Okay, anyway. Moving on. The first laws are mostly level 1 laws. These are mostly level 1 laws, but we can use them for level 2 and level 3 also, okay? We can use these for level 1 and level 2 also. I'm going to give you the rule, the name of the rule, the math, and then an example. So the first rule is the constant rule. Constant. What's it saying? All right, let me call. The constant rule says that if we have the limit as x approaches a of f, not f of x. Sorry, I'm distracted. Let me wait. Hi, I have a student trying to make a pass, but it's not working. Yeah. Okay, thanks. Bye. All right, they're coming. They're coming. That's not culture. It says the limit as x approaches a of some constant k. Does anybody know what a constant is? It's the same. Yes, constant means like it's repeating, but it's the same. Yes, so constant is the same. But in math, constant is a number without a variable. Constant is a number without variable. Like if you did y equals mx plus b, b is your constant, right? Does not have a variable, okay? So if you have something that has a limit where there's no variable, the limit is just that number. Ladies, I'm going to have to split you up. So for example, if I have the limit as x approaches 6 of 72, this is a constant. Why is this a constant? Because of what? Nope, not the higher number. Why is 72 a constant? What did I say a constant was? A number that doesn't have a variable. Yeah, it is the same in like, he's right there. It is the same when we're talking about like English and history, like it's constant, it's never changing. That's what you mean. This is a constant because it will not change. So it doesn't have a variable, and that means it's 72, okay? So again, this is a constant, which is a number without a variable. So if you get something without a variable, that is just the limit, okay? Let me show you what I mean graphically, since we've been seeing graphs and limits, okay? So let's say I have this graph. Let me use a different color. This is y equals 72, okay? And then this is 6. What we have been doing in class with our graphs is that we would draw the line going up and down, right, to find the limit. And then we would go from the left, figure out what that is, and then from the right, figure out what that is. And then this is 72. So that's what it looks like graphically for a constant. I know some of you were confused. So this is what it looks like graphically, and this is what it looks like numerically. We'll do examples in a minute, okay? Am I going too fast? Okay. Our next rule is the linear rule. The linear rule says that if we have the limit as x approaches a of x, then the limit is a. What? Oh, that was just you clearing your throat. Okay. I thought something was wrong. So, for example, if I have the limit as x approaches 6 of x, let's do negative 6 of x. What is the limit? Negative 6. Anybody? I'll wait to answer this question or ask this question because people are still writing. Can anybody see what I did between the a and the x? What did I do?
The same value.
Yes and no. I know what you're saying. Like it's, yeah. It will be the same value. But what are we doing mathematically? Anybody know? Replacing.
Or replacing a with negative 6.
Mm-hmm. What is that called mathematically?
I don't know.
Starts with an S.
Subtract?
Nope.
No, substitution.
Substitution. We're substituting in my a value for x. Okay? No, that's okay. We're close. So let me show you what that looks like graphically. So this is what Miguel was asking or saying. So this is the graph of y equals x. This is the graph of y equals x. So if I did negative 6, ladies, negative 6 is over here. So again, I'll draw the line like we did way in the beginning of limits. And I come from the left. That's negative 6. and I come from the right, that's negative 6. That's why the limit is negative 6. So here's using algebraic, and here is using graphs. Okay? So we're connecting the two. Questions? What's wrong, Andrea? You sure? Okay. Now the next one I'm going to give you is not a rule that you'll find in math books, but I made it up so to make sure that not made it up. I created my own rule so that it's accessible to you. It's still under linear. Can you see this color? Someone said no. So I will do this. Now can you see this color? Okay. mx plus b. Okay? What this is saying is now I have, as Jalen and Adira were talking about, we're replacing or substituting in the a for x. Yeah. So it's going to be m times a plus b. Can I zoom up because I know some of you are. Is that good? Much better? Okay. So for example, if I have the limit as x approaches 2 of 9x plus 7, as they both said, I'm going to take this 2 and do what to it? Replace, substitute. So it's going to be 9 times 2 plus 7. 18 plus 7 is 25. I believe that's 25. Questions? Okay. Am I moving too fast? Okay. Can I go? Or are people still writing? I can go. All right. If anybody needs it, let me know. Okay. Now, before we get to the examples, I'm going to give you level 2 and level 3 laws, okay? Now you can go. I'm sorry. Hear me. You're welcome. Is it not working still? Oh. So again, I'm going to give you the name, the rule, but I'm not going to give you an example. Okay? I'm going to give you the name, the rule, but I'm not going to give you the example. Don't give me that pouty face. It's because I want to make sure I'm getting to the examples. Does that make sense what I'm saying? I want to make sure that I'm getting to the examples. All right. All right, the first one. Sorry. First, we have to say the limit as x approaches a of f of x is equal to the limit 1. What's up? Are we good? You have a question? Sure? Okay. If you need the notes, Mia has them if I went too fast, okay? Okay. So first we have to talk about limits existing. A limit has to exist in order for us to do these rules, okay? If it tells us the limit doesn't exist, then we can't use them. We're going to have multiple functions. So we have I put the same letter. We have 2 different functions with possibly 2 limits. They can have the same limit, but we're going to assume that they have different limits for now. So these are limits that exist. for that function. And the other thing that needs to happen in order for us to use these laws is that these two a's, these two x values, have to be the same. If one says 6 and one says -1, you cannot use it. Okay? If one says 6 and one says -1, you cannot use it. Alright, then let's get to the rules. Again, I'm just going to give you the name and the rule, and then we'll get to the examples and I'll tell you which ones we're using. Alright, first one is addition. So if we have the limit as x approaches a of two functions being added together, then the limit law tells me I can separate the two Am I off screen? I can separate the two and find them and separate them and find it separately if needed. So that will give me L1 plus L2. So again, it tells me f of x is L1. Here's L1. Then we have addition. And then L2. Okay. I'm going to go a little faster for these next next three, because all it's doing is changing the operation. That's it. That's all it's doing is changing the operation. So, the next one is subtraction. What do we think is going to be between the two? A minus sign. Okay? So, everything's going to be the same except what? The minus. So, it's the limit as x approaches a of f of x plus g of x. Nope, not plus. What should go there? Minus. Sorry about that. I'm going too fast for myself. So you can wait until I write this down, or you can just copy from the top and instead put a subtraction sign. Okay. What do we think the next rule is? Either one. Multiplication or division. So now, instead of there being a subtraction sign between them, what's going to be between them? Multiplication. Multiplication. Sorry. So we have the limit as x approaches a of f of x times g of x is equal to the limit as x approaches a of f of x. I'm going to use the little dot for times. G of x, which is equal to the limit 1 times the limit 2. Can I move up? No? I mean, like right there, though. Okay.
I'm sorry. Can you not love me, please? Please.
Now what's next? We've done addition, subtraction, multiplication, division. I'll give this to you in a second, okay?
Huh?
I'll give this to you in a second. So now we have a quotient. And we can separate it so that the numerator is 1 and the denominator is the other. What cannot we not divide by in math? What can't we divide by in math? There's one number we can never divide by. 0. L2, so the limit at the denominator cannot equal to 0. This is very important, and we'll talk about this for level 4 and possibly in the next coming weeks. Okay? We have one more limit rule. Yadira, come grab this.
Huh?
Can anybody guess what the last limit rule is? Ooh, so close to exponents. So close, so close. Oh, sorry. Anyway, it has something to do with exponents. Are we done with this? No? Okay. Let me know when you're ready. It's close. It's the inverse of exponents. It's one of the things. Yeah. So we're going to be talking about roots. Okay? Yeah. Radicals, roots. Okay. Good job. I can't. I froze it. She hasn't. Good? Okay. All right. Last one is called the radical rule. The radical rule says that if we have the limit as x approaches a of the nth root, so n is like square root, cubed root, fourth root, okay? We can then just find the limit and take that root. So all that is the nth root of L1. As a side note, I'll just wait until you guys are done copying this down. If we had this radical, what is n? How about this? if we had this radical, what's n? 3. This is the cubed root. What is this called? Square root. So what would n be? 2. Very good. This is the only, okay, this is one of the very few things that if there is no number there, the understood number is not 1. Here, the understood number is 2. Okay? So keep that in mind. The understood root is 2. When you're done copying this down, we're not going, I need you to take out the example sheet I gave you, but we're going to continue this in our notes because there's not going to be enough room on this sheet. Okay? Got it? Yeah. All right. Are we ready? Ready? Yadira, Mia, do any of you need this one? No? Okay. All right, let's go over level 1, example 1. Okay. So if we look at number 1, we have the limit as x approaches 6 of 7. What rule is this? What rule is this? Starts with a C. Constant rule, which means that then this is going to be what? 7. Questions?
Is this on our notebook or on the paper?
This is up to you. I suggest you doing it in your notebook because there might not be enough room. But if you want to do it on the paper, I have you have the paper so this way you don't have to write down all of the problems. So it's up to you. If you want to write on the paper, write on the paper. If you want to write it in your notebook, write in your notebook. Sound good? Just keep in mind you might not have enough room. Okay? All right. Are there any questions on that one? Straightforward. Everybody should get a 1. Number 2. We have the limit as x approaches 2 of x. What rule is this? Starts with an L. Linear. So what am I going to do with this 2? Yeah, what mathematical substitution? So we're taking 2 and substituting it in for x. That's your limit. Am I going too fast? Are we sure? Okay. All right. Level 1, the last problem for level 1. We have the limit as x approaches negative 6 of 9 minus 8x. So I'm going to do what with negative 6? Substitute. So I'm going to take negative 6 and substitute it in for x. That gives me 9 minus 8 times negative 6, and that is 57. Questions? So that's level 1. That's level 1. We should all be getting level 1. Ed, where are you going? After Mega, PCS. Are we good? No. Who said no? Who said no? Oh, okay.
Okay, I'm ready.
Sure? Okay. All right, level 2. Now, I want to show you the difference between level 2 and level 3. Hey. Okay. Can I show you the difference between level 2 and level 3? Okay. Level 2 is going to give you the limit. The limit is given. Okay? The limit is given. Did you get her phone out of her back pocket? Yeah. Yeah.
I don't have anything. It's my wallet.
There were 2 things in her back pocket. A wallet and a phone.
I just think like that. Wait till I learn.
Yeah, I know. I love you guys too, most of the time. Level 3 only gives you the functions. So you need to find the limit. Okay? That is going to be the difference between 2 and 3. Alright? It seems like it's not attainable, but it is. Just wait until you see the examples. Okay? Alright, let's get to level 2. How much time do I got? I got 15 minutes. Oh man, we're not going to get through them all. So we'll get through 3 tomorrow. Alright, level 2. What? In your notebooks or on the piece of paper? It's up to you. You decide. You decide. Oh, so aggressive. I mean, these are on that sheet, so I just know I'm not going to have room to do it. Okay. Okay, so we need to split this up. And the reason I want you to split it up is because once we get more complicated things, it will probably be easier just to split the stuff up. Okay? Oh, I'm sorry I'm boring you, but not really. So we have the limit as x approaches a of f of x plus the limit as x approaches a of 2g of x. Okay? What does this 2 mean? Okay, if we don't know. What is the operation going on between 2 and g of x? No. Between 2 and g of x. Multiplication. Okay, remember if there's no operation, the understood operation is multiplication. Okay? So when we have g of x, what do you think we're going to need to do? Multiply? Multiply by 2. You know. Do we know what f of x limit is? Yes, look in our paper. Look on our paper. Lalo and Rodrigo, you good? No? Do you need to go get water? It's not A. We don't know? Yes, it's 2. It's 2. The limit as f of x, x approaches a of f of x is 2. Do you see what I'm getting at now? You sure? Okay. What is the limit of g of x? Nope, not 2. Negative 4, where are you getting that from? Where are you getting that from? The given, right above that. Do you want me to show you? You sure? Okay. If I do my math right, the answer to this is negative 6. Thanks for double checking your math. Sometimes I am wrong. Yeah, I know. I wish I could just give you these and you figure it out on your own. Good? No? Yes? Okay. Number 2. We have the limit as x. Can I just split it up since you have it on your paper? Thank you. I'm not going to rewrite it. So I'm going to split it up. H of x minus the limit as x approaches a of 3 g of x plus the limit as x approaches a. What did I do? What? Yes. Sorry. Of 1. Do you need to stand up? Okay. Okay. Are we good? Can I go? Okay. What is the limit of h of x? Don't say we don't know. 0. What is the limit of g of x? -4. What is the limit of 1? Ooh. What is the limit of 1? What is this called? It's called a constant. So what's the limit of a constant? 1. For this one, yes, it is 1. If I did my math right, this is 13. No, yes, maybe so.
Okay.
Are we getting it? No? What's wrong? Well, that wasn't my question. Like, my question was, are we understanding it? Not, are these problems too long?
I feel like we don't get it.
Do we? Do we get it? Kind of? Okay. Can I skip to a harder one?
No.
No. Okay. Well then. Let's move on to, we're only on number 3. Jesus. Heaven Christ. Lord Almighty. We are gonna skip number, no we're not. No we're not. We're just gonna put this, again, I'm not rewriting it, I'm just moving on to the next step. For exponents, they just go on the outside. Okay? We just split it up, move it on the outside. You look great. You don't need to, you don't need a mirror. So what is the limit of g of x? What is the limit of g of x? Wake up. Do we not know? Thank you. I wish other people would talk, but thank you. I appreciate it. All right, seniors. When you're done writing this down, before I give you the answer, you've got to listen to me. You have to listen to me. Gio, sit up. Gio Lopez, sit up. Thank you, ma'am. Seniors, grab our calculator. I don't know how many times I have to say this to seniors. Put this in your calculator, -4 squared. Just like that, no parentheses. -4 squared. Put that in the calculator. -4 squared. It gives you -16, right? Now, put this in the calculator.
16.
That gives you 16. They are not the same. Not the same. Make sure if you have a negative, you are putting it in parentheses. No, we don't have much time. Okay? Put it in parentheses. Because your calculator does order of operations. It will do your exponents because there's no parentheses. And then it will multiply by -1. Okay? Put it in parentheses. Are you slamming? Are you clapping your hands while I slam? Okay. Alright. Next one, number 4. Again, I'm not going to rewrite it. So I'm just going to do this. The cubed root of the limit as x approaches a of 6 plus f of x. What is the limit of f of x? 2. Miguel, I don't think we have time. What? Your language. Okay, then put it up there and get another one. All right. Without the calculator, what is the cubed root of 8? No. 2. It's 2. Does anybody know how to put this in their calculator?
Yeah.
We do? What do we push? Second? Nope. Alexander, can you use your calculator? That's your name, right? Yeah. Okay. You do not push second. What you're going to push is you're going to push math. And then for number 4, it is the cubed root. Okay? Oh. Okay? Thank you. We have, yeah, we don't have time. Okay, we've got 5 minutes. Let's put our